All right, next question. So, how will users view the details of a given problem and code a solution? Fuck. Okay, so in order to view the details of a given problem, um, basically the client's going to make a request via the API gateway to the problem service. Then they'll go to the database and we'll basically fetch the problem by its ID. We'll get the description, code stubs, test cases, etc. They'll go back to the client. The client's going to now render it in the browser. And within the browser, they'll be able to code the solution. Valid. Um, okay, so how will users submit their solution and have their code executed? So this is like, I believe, the second requirement. So you have your client, and within the client, you select the programming language, and then we'll go back to the gateway. And this is going to be a per submission. Returns a submission ID. It will go to the testing service. We'll just call it a submission service. And the submission service will basically execute the person's code on their given language. So within this, we'll probably use a technology like Docker. And we'll just have different runtimes like, oops, what is happening? Python runtime, Java runtime. And the feedback we'll just pull. So we'll just go get the submission bias ID. And the code's going to be executed in a sandbox environment. We'll get the result, and we'll also put it in the submission data store. No, like all of these databases can actually be the same, so it's not actually a big issue. And this is our next entity, which is the solution. It just has a solution ID. Results. So results will just be like, maybe it's going to be test cases passed. So language, some enum. just an array of case IDs. Cool. So when we make a submission, we again just make a post request to the submission API that calls the submission service for the code and language. And once this code and language is called, we make a request to a sandbox environment, which will just execute the code against the test cases. So actually, the sandbox environment will also need to be fed the data from the database. For getting the test cases, we execute the code, we figure out how many solutions were right or wrong, and then we publish that data to the submission database, and we store the solution, which has ID, whether it's correct, the language, and the number of test cases it failed. And once that's done, we have this data here. And what we can now do is from the client, we just keep polling the submission by its ID, because when we make the submission, we return the submission ID. And at the moment, it'll just be like, maybe you'll say it's like pending. We'll have a pending status. Or actually, we'll use a created at. Created at and completed at. And we can have some conditions. If like something's been running for too long, then we consider that something's gone wrong and we'll get the front end to retry it. Fuck off. Okay, so when we make a submission via the submission API. Fuck. So in order to actually fetch the submissions for the competition, we can just write an SQL query to evaluate the correct solutions. So let's just add the competition entity ID, which has some problems. It's just a small array. So we'll probably just do something like select all from submission where competition ID in whatever the idea for competition is. And so we get all the submissions where this and where status. Correct equals to correct is true. Oops. By group by user ID. Score yeah, or something's more complicated. Okay, so in order to get the live leaderboard, we'll probably just use like a materialized view from like the submissions database. We can just do something like select user ID, count of the distinct problem IDs, where competition ID is the competition that we're looking at, and where the correct problems is one. We can do a group by user and order by the score, which is just basically the number of problems which are being solved. Obviously, this is like a very simplistic thing. We can further like improve the score calculation here by changing the query. But after creating this materialized view, shouldn't be that expensive later on to just query this, especially to get something like the top 10. So this gateway, we're again just going to make a query, which is just going to be a get request that we have already defined in the leaderboard. And we'll just call the competition service. So in order to create a sandbox environment, we can use a technology like Docker. So we share the same kernel, but then we can create an environment where we don't provide access to like the root level um, user files, network, etc. And yeah, the submission service can call these containers and execute the code in a manner where we also control the CPU time and the memory usage per run, because we don't want like overflows, memory overflows, or high CPU usage just from one process. Moreover, we can use technologies like just user groups when executing these Docker containers. So we can create a sandbox user group with very limited privileges, because in our case, we just want to be executing the Python or Java code and not touching any other files, not touching the file system. What we can do is we can paginate the leaderboard and only care about maybe the top 20 users who are on the leaderboard. And what we can do here is when a submission comes in, we check whether this submission will eventually have a score greater than the top 20. And if it does, then we basically cache and validate and also send like an event to the client. It could just be a server side event after the submission has been completed to all other participants. Cool. In order to not drop the request, we basically want to make sure that oops, So when we initially receive a submission, what we can do is we can just append that to a queue. And so we produce an event, put it in, for example, RabbitMQ, and then Docker containers can actually be like an ASG. And these are the consumers of the queue. And what they can do is once they've executed the code, we move that, we separate the service, we isolate it. And after isolating the code, we can then produce like a solution. And we have a separate consumer that updates the submission database. And when the submission database has been updated, so we'll call this solution event, and the solution event will then go to solution consumer. And update the submission database, and the polling can still continue, and these will be not as inefficient. We can also use like caching as well in the middle. Solution available cache, where we just have a solution ID, and if the solution is now available, then the submission service will then fetch from the database the actual solution results. Okay, so the stuff that we're gonna cover next, coding wise. So I just need to make sure I remember at least one graph algo, to be honest. I can't remember like fuck. BSD, DFS, Elevate. Unit array of variable pairs, equations, and an array of real numbers, values. So we have A, B, B, C. Man, this is a fun one. So like we're basically multiplying the numbers. So AC is just gonna be 2 times 3 is 6. And we just want to see if there's a cross path from Q1 to Q2. Okay, so probably just gonna evaluate the queries later. First, we want to construct this little graph. Man, that's gonna be annoying. So AB is a node and going to BC. So AB can go to any other node that begins with a B. But in order to build this graph, we're gonna have to figure out everything that starts with a B really, really quickly. So what we can do is we'll build a dictionary. Called a node starting dictionary, and we'll just go E0 append and now that we know like what every, so we should be able to query something like at B and get everything like B whatever BX. So the next thing we want to do is construct the actual graph. Okay, actually not really. I think that's enough. Now we just go explore this graph and just run a DFS on it until we reach the desired point. Something that ends with a C. So we're gonna start off at Start off at Q1. Next possible nodes are all of these. So visit, we mark it as visited. Up. Dot add v1. Next nodes zero. Query one.
What, Tonton?